Alright, so here's a problem called the square deal. And this is a problem that I'm grabbing from the 1958 issue of Scientific American, and I like this problem because it seems like you can't solve it at first. It seems like they're not even giving you anything to work with. But they tell you, as some of my students have underlined, that square C is 64 square units, and that square D is 81 square units. So that's all they're giving us, and I think it's really neat that just from that information you can solve this whole problem. So square C, it's right here. All right, this is square C. And we know that the area of square C, it says, is 64 units. So what does that mean? Well, if the area is 64, well, every side of a square has to be the same. So that means this side has to be 8, and then this side has to be 8. And the reason is, of course, that 8 times 8 is 64. And this just goes to the idea of area and square roots. If the square root of 64 is 8, that means that a square with an area of 64, if you take the square root, you get the length on one of the sides. And that's 8. So let's label that and get started on this problem. So C, every side of C is 8 units. And then D, well, the area of D is right here. And the area of that is 81 square units. So again, if the area is 81, we take the square root to find how long each side is. And there, 9 times 9 is 81. So the side of each square is 9 units. And isn't that cool? That's all we need. So now we have this little square right here. How large is that square? Well, you can almost see it right here. This length right here is 9 units long, right? And this length right here is 8 units long, and this little green square makes the difference. So I is a really little 1 by 1 square. Because again, this is 9 units, that's only 8, and the I makes the difference. So that's a 1 by 1 square. And now we've got all we need to solve the problem. Because now look at E. E, the side of E is just D, 9 units plus 1, the little I unit. So how long is E? Well, it's going to be 10 on each side. Right? So that's E. We're done with that square. And we can go any way we want now. I'm going to work up here towards B. B is this large square right here. And I want to know I want to know what the area of that is. Do I have enough to figure that out? Maybe not. Let me go for H and G, different color. H is right here. So how long is H? So to find H, you can think of H as almost the difference between this little I square and the C square. Because what's happening here is that this side of C is 8 units long. And this little green square is 1 unit. And if you look at H, if you take H and you add it to that little 1 unit, you get the full side of C. So you're asking yourself now, what do I have to add to 1 to get 8? Well, the answer there is 7. So 7 and 1 is 8. So each side of H is 7 units. And now we can figure out B. Because what is this side right here of B? Well, that's just the sum of C and H. And that's 8 and 7. That's 15 on each side. This is 15, and that's 15. And now we've got enough to figure out G. Now G is what confused me the first time. This square threw me off. Don't rush on this step, but you can see that what G is. It's a combination of the little green square and E and H. Those 3 squares help us figure out what G is. A couple ways to look at it. First of all, D and E all together. That's from here all the way through. That's 19 units. And we know that C, which is 8 units, and H, which is 7 units, is 15. So that means, let me just grab a different color here, I think pink. So from here all the way to here is 15 units. And from here all the way to here is 19 units. So G is just the difference between 15 and 19. So every side of G is 4. It's just how far apart these 2 pink lines are. So let me erase that bottom pink line. Let me fix that. Okay, so again, this whole length is 19, right? 9 and 10. This is 15, so G, each side of G needs to be 4 units. Let me just check. 4 plus 7 plus 8 is 19. Okay, so that works. Another way to think about it, initially I said, well, if this whole thing right here, E is 10 units, and H is 7 units, right? How much of H overlaps with E? Well, 6 units, because this one little extra right here is taken up by the little square. So for H, we have 6 units on this side of H, plus something has to equal the full side of E, which is 10, which is 6 and 4. So G is 4 by 4 square. And now we have to figure out F. Well, we don't have to, but I'm going to. F is the next square I'm going to figure out, right, in brown. So how large is F? Well, F is just the sum of G and E, right? It's 4 by 10. 4 and 10 together, that's 14 units. And then last but not least, we have the A square, this big square right here. Now A is the largest square, and to figure out the size of A, I'm just going to add F and G, right? Because F is from here to here on the side of A, and G is the remaining part. So each side of A is 18 units. So what do they want to know? Oh, what are the areas of the other 7 squares? Okay, so we know that C has an area of 64, they gave us that. D has an area of 81. Okay, so that's this and this. I has an area of 1 square. H has an area of 7 by 7, that's 49 squares. G has an area of 16, that's 4 by 4. E has an area of 10 by 10, or 100. And then we're almost done. B is 15 by 15, which is 225. That's B. F is 14 by 14, which is 196. And A is 18 by 18, which I'm going to work out actually. So 18 by 18. What I'm going to do is I'm going to think of 16 times 20. This is one of my favorite techniques. And that I know, well, 16 times 20. I'm going to think of 20 times 10, which is 200, plus 20 times 6, which is 120. And then I'm going to add, if you notice here, I added 2 and I took away 2. A shortcut that I'll go over in other videos is then to add 4. Right, you add the square of what you took away or subtracted, and this will give you the answer, which is 324 for the area of A. And just to check, what is 18 squared? 18 times 18 times 18. If I got it right. Yep, 324. Okay, so that's a fun problem, I think. And it's, again, just interesting that you can, with such little amount of information that's given to you, you have everything you need to actually solve this problem. All right, thanks.